Hey everybody, so in today's lesson we're going to be working on special right triangles. Before we do so, we'll just do a quick practice with what you've talked about yesterday, which was the Pythagorean theorem. The only difference with these questions though is instead of it saying round to the nearest hundredth, we are going to leave our answer in simplest radical form. So this was a topic from Algebra 1, so we'll just do a quick refresher of that, and as we go through this lesson, we're going to reinforce that topic. If you do need any extra help on that, make sure you do reach out to us, or you do find some YouTube videos or something like that that can help you with simplifying radicals, rationalizing denominators, and those topics. Okay, so the first one, we have a right triangle. The hypotenuse is x, so that would be our c. So we're going to do a squared plus b squared equals c squared. So that would be 5 squared plus 10 squared equals x squared. We're going to simplify 5 squared and 10 squared. That would become 125. And then to figure out what x is, we take the square root of both sides. But 125 is not a perfect square. Remember your perfect squares. They're 2 times 2, which is 4, and then 9, and then 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 49, and so on, 64. So those are all of your perfect squares. 125 is not one of those numbers. So 10 squared is 100, and then 11 squared is 121, which is close, and then 12 squared is 144. So that means 125 is not one of our perfect squares. So if we take the square root, we end up getting a decimal. So to write it as simple as radical form, what you want to do is you want to take that 125, break it up into a perfect square times another number. You want to always pick the biggest perfect square that divides in. So 25 is the biggest perfect square that divides in to 125. And the square root of 25 is 5. So our final answer is 5 radical 5. That's simplest radical form. All right, number 2, the hypotenuse is x here. So we're going to do 2 squared plus 3 squared equals x squared. 2 squared is 4, 3 squared is 9, 9 plus 4 is 13, so we get 13 equals x squared, and then we take the square root of both sides, and we get x equals the square root of 13. That one can't reduce anymore because there's no perfect square that divides in to 13, so that is simplest radical form. All right, number 3, we have to rationalize that number. Anytime you have an irrational number, such as a square root in the denominator of a fraction, you have to rationalize it. Now, the way that you most likely learned how to rationalize the denominator is just multiply that denominator by itself. So to get rid of the square root of 3, I just multiply it by square root of 3, because 3 times 3 is 9, and as we know, the square root of 9 is 3. So that's what we're going to do here. Multiply the top and bottom by the square root of 3, which was the original denominator. The top 12 times radical 3 becomes 12 radical 3. Radical 3 times radical 3 is the square root of 9, which becomes 3. And then we have 12 over 3 reduces to 4, so our final answer is 4 radical 3. And then for number 4, this one doesn't have an irrational denominator, but that square root of 20 can be reduced because square root of 4 divides evenly into the square root of 20. So the square root of 4 divides into the square root of 25 times. So we can break the square root of 20 into radical 4 times radical 5. The square root of 4 becomes 2. So it becomes 2 square root of 5 over 2. And then notice we have a 2 on the top and the bottom. They're going to cancel each other. So our final answer is just the square root of 5. All right, so that's just a little refresher on some of the topics, and we're going to be using those throughout this lesson. All right, so the objectives for today: justify and apply properties of 45, 45, 90 triangles and 30, 60, 90 triangles. So those are our two special right triangles. So a diagonal of a square. So we talked about in chapter 6 squares. If you draw the diagonal of a square, it divides it into two congruent isosceles right triangles. And since the base angles of an isosceles triangle are congruent, the measure of each acute angle is 45 degrees. So another name for an isosceles right triangle is a 45, 45, 90 triangle. So this picture that we have down below is a square. Notice how the sides are the same, so these are both the same number. And if you draw this diagonal, we have a 45 here and a 45 here, and then this would be our 90. So that's what a 45, 45, 90 looks like. You can use the Pythagorean theorem to find the relationship among the sides. So if we were to do this side squared plus this side squared, it would equal this side squared using the Pythagorean theorem. And then the next theorem shows us that this length is always going to be whatever the leg was times the square root of 2. So that's why it's considered a special right triangle, because no matter what type of or what size your 45, 45, 90 triangle is, if you have one of the lengths of the legs and you multiply it by the square root of 2, you're always going to get the length of the hypotenuse. So if the length of BC is 5, then the hypotenuse is 5 times the square root of 2. If the length of the leg is 6, the length of the hypotenuse is 6 times the square root of 2, and so on. So in a 45, 45, 90, both the legs are congruent. So if you know one of the legs, then you know the other leg. And the length of the hypotenuse is the length of the leg times the square root of 2. So that's what these little formulas are telling us. All right, now down below, this is kind of like a little cheat sheet in a way. I'm going to attach this to the assignment today. This is basically saying, if I gave you a special right triangle of 45, 45, 90, and let's say that I told you the length of the leg, and you wanted the length of the other leg, what do? You just copy the same number, because the legs in a 45, 45, 90 are always the same length. But what if you have the short leg, and you want the hypotenuse? Well, you multiply the leg by the square root of 2. And then what if you have the hypotenuse but you want the leg? You divide the hypotenuse by the square root of 2 and then simplify. So let's take a look at some examples. So here's the first one. Find the value of x, give your answer in simplest radical form. So the first thing you might notice, this is a 45, 45, 90, because if this is 90 and this is 45, and all triangles add up to 180, we do 180 minus 90 minus 45, and we would get that the other angle is also 45 degrees. So it is a 45, 45, 90 triangle with a leg length of 8. So we have the leg, we want the hypotenuse. What do? The hypotenuse equals the leg times the square root of 2. So it's just going to be 8 times the square root of 2. Now it says leave it in simplest radical form. The good part about this is we're done. We don't even need to plug it into the calculator and get a decimal answer. So the answer is just 8 square root of 2. That's the length of the hypotenuse. All right, let's try another one. So in this one, we're given the length of 5. 5 is the hypotenuse. So now we're given the hypotenuse, but we want the length of the leg. So what's the rule? We do the hypotenuse equals the leg times the square root of 2. So the hypotenuse is 5. It's equal to the leg, which is x times the square root of 2. So we plug that in. Hypotenuse equals leg times the square root of 2. Now we need to figure out what x is. So we just divide both sides by the square root of 2, and we end up getting 5 over the square root of 2. But just like we did in the warm-up, we can't have a irrational number in the denominator, so we have to rationalize that by multiplying the top and bottom by the square root of 2. So when we do that, we end up getting 5 square root of 2 over 2, and that's our simplest radical form. So we can't reduce this anymore. 5 and 2 don't reduce at all. You would get a decimal, and the denominator is a rational number, so that's our final answer. All right, another example. The leg is given to us. The leg is 10 radical 2. They want us to find the hypotenuse. So if we have the leg and we want the hypotenuse, we multiply the leg times the square root of 2. So the hypotenuse equals leg times square root of 2. So that means x equals 10 radical 2 times radical 2. Now we need to simplify this. You don't want to have two different radicals in the same expression here, because you can simplify them. You can multiply radicals together with each other. So the square root of 2 times the square root of 2 becomes the square root of 4. And then the square root of 4 is 2. So then 10 times 2 is just 20. So the hypotenuse, that length is going to be 20. All right, another example, you're given the hypotenuse is 16, and they want you to find the leg. So the hypotenuse equals the leg times the square root of 2. So 16 equals x times the square root of 2. To solve for x, we divide by the square root of 2. So we get 16 over the square root of 2 equals x. In this case, we have an irrational number in the denominator, so we have to rationalize that. So we multiply the top and bottom by the square root of 2. So 16 over radical 2, we multiply it by radical 2 over radical 2. 16 times the square root of 2 becomes 16 square root of 2. Square root of 2 times square root of 2 becomes the square root of 4, which is 2. And then 16 over 2 divides to 8. So our answer is 8 radical 2. That's the length of our leg. All right, the next type of special right triangle is a 30, 60, 90 triangle. Now, in a 30, 60, 90 triangle, all three angles are different, And we've talked about that if all the angles are different, then all the sides are also going to be different. But in a 45-45-90, two of the angles were the same, so that means two of the sides were the same. So the only thing with this, it still has special rules. You only need to know one of the side lengths to find the other side lengths. Unlike with the Pythagorean theorem, you need to know two side lengths to find the other side length. But the rules apply as follows. So in a 30-60-90 triangle, the length of the hypotenuse is 2 times the length of the shorter leg, and the length of the longer leg is the length of the shorter leg times the square root of 3. So basically, the short leg, the one that's across from the 30-degree angle, this is always going to be your short leg, because remember, the shortest side is always across from the smallest angle. So this is kind of like your home base. If they give you the hypotenuse, the next thing you want to find is the short leg. If they give you the long leg, the next thing you want to always find is the short leg. So this is like your home base. You can't go from long leg to hypotenuse or from hypotenuse to long leg. You always need to kind of go back to the short leg and then find the next one. And then go back to the short leg and then find the next one. Hope you get the point there. So here's the rules. The hypotenuse is just the short leg times 2. The long leg is just the short leg times the square root of 3. So don't get confused with the previous 45-45-90, where you multiplied by the square root of 2. With the 30-60-90, you multiply the short leg by the square root of 3 to get the long leg. So here's the rules, the little cheat sheet that I made up. So if you have the shortest leg and you want the longer leg, you multiply by the square root of 3. If you have the short leg and you want the hypotenuse, you multiply by 2. If you have the long leg and you want the short leg, you divide by the square root of 3. And if you have the hypotenuse and you want the short leg, you divide by 2. So those are the only 4 rules you really need to remember, and then you need to remember to simplify. So here's an example. In this question, you have the hypotenuse. It's across from the 90-degree angle, so we have the hypotenuse. So if we have the hypotenuse, the only place we can go next is to the short leg. We can't go from hypotenuse to long leg, we have to go from hypotenuse to short leg. So the rule was, if you have the hypotenuse and you want the short leg, you just divide by 2. So the hypotenuse equals 2 times the short leg, so we get 22 equals 2 times the short leg. Divide by 2, which is the rule, and you get that the short leg is 11. Now that we know the short leg is 11, now we can find the long leg. So the rule is, if you have the short leg and you want the long leg, we multiply by the square root of 3. So the long leg equals the short leg, which is 11 times the square root of 3. So we substitute in 11, and we get 11 square root of 3. That can't be simplified anymore. All right, the next example, they give us the side that's across from the 60-degree angle, which is considered the long leg. If you have the long leg, the only place you can go from there is to the short leg. The rule is, if you have the long leg and you want the short leg, you divide by the square root of 3. So we're going to divide by the square root of 3. So the long leg equals the short leg times the square root of 3. So we divide by the square root of 3. And we get 15 over the square root of 3. Since we have an irrational number in the denominator, we have to rationalize that by multiplying the top and bottom by the square root of 3. So when we do that, 15 times the square root of 3 becomes 15 square root of 3. Square root of 3 times the square root of 3 becomes the square root of 9, which is 3. And then 15 over 3 reduces to 5, so we get 5 square root of 3 as our short leg. Now that we have the short leg, we can get the hypotenuse. So to find the hypotenuse, we do the short leg times the square, or the short leg times 2. So we're going to do 2 times 5 radical 3. And to simplify this one, we can multiply the whole numbers together. 2 times 5 becomes 10, so our answer would be 10 square root of 3. Okay, in our next example, we're given the hypotenuse. So it's a 30-60-90, we have the hypotenuse. We go from the hypotenuse to the short leg. So the rule is, if you have the hypotenuse and you want the short leg, you divide by 2. So we're going to do 18 radical 3 divided by 2, and we get 9 radical 3. So the 18 over 2 reduces to 9 radical 3. Now that we have the short leg, we can get the long leg. So we're going to take the short leg and multiply it by the square root of 3. So we do 9 radical 3 times radical 3. The square root of 3 times the square root of 3 becomes the square root of 9. The square root of 9 is 3, so we do 9 times 3, which is 27. So the length of the long leg is 27. Okay, in the next example, they give us the short leg. That's the best one to be given. If you have the short leg, all you need to do is multiply by 2 to get the hypotenuse and multiply by the square root of 3 to get the long leg. So to find the long leg, we're just going to do 5 times the square root of 3, which doesn't reduce, so that's just our answer. To get the hypotenuse, we do 2 times the short leg, which is 2 times 5, so the hypotenuse is 10. That's the best case scenario when they give you a whole number as the short leg. All right, and then the next one, the hypotenuse is 24. Now, if we have the hypotenuse, the only place we can go is the short leg. So to go from hypotenuse to short leg, we divide by 2. 24 divided by 2 is 12, so the short leg is 12. And then if the short leg is 12, to get the long leg, we multiply the short leg by the square root of 3. So we do 12 times the square root of 3, which is just 12 square root of 3. So that's how we use that. All right, and the next one. They give us the side that's across from the 60-degree angle, which is the long leg. So we go from the long leg to the short leg by dividing by the square root of 3. So 9 divided by the square root of 3, that's going to give us y, which is the short leg. We need to rationalize that by multiplying the top and bottom by the square root of 3. The top, 9 times the square root of 3 becomes 9 square root of 3. Square root of 3 times the square root of 3 becomes 3. And then 9 divided by 3 becomes 3, so we get 3 square root of 3 as our short leg. If the short leg is 3 square root of 3, we find the hypotenuse by multiplying by 2. So 2 times 3 square root of 3, we multiply the whole numbers together. 2 times 3 becomes 6, so we get 6 radical 3. That's our hypotenuse. All right, so that's all we have for this lesson. If you do have any questions, make sure that you do reach out to us, and hopefully we can answer your questions for you. We are going to have a quiz on the next school day, which will be Monday. Have a great day.